Hello, today we are going to be talking about key features of graphs. So this unit we've been focusing just on graphs of different functions, and each of these graphs are going to have certain key features or characteristics that we look for when we are identifying them or working with them. Some of these you've already learned about in your math journey, but some of these might be new to you. So the first thing we're going to talk about are your x and y intercepts. Hopefully those are familiar. You've been using intercepts for a couple years now. But just as a recap, again, an intercept is where your graph is going to be crossing either the x-axis or the y-axis. And we do write those usually as an ordered pair. So for an x-axis, a right here is going to be the number that it's crossing through the x-axis, and then it's always going to be 0 for y, since if you're on the x-axis, your y is 0. And then for the y-intercept, it's the opposite, because the x will always be 0 when you are on the y-axis, and then b is going to be your height for your number on the y-axis. So the next thing we're going to look at are going to be what we call relative maximum and minimums. So a relative maximum occurs when your y value is greater than all the y values near it. So it's not an overall maximum, but it's just a maximum relative to the points around it. So an example of that is like if I have a cubic function, remember those give this kind of weird little swoopy shape. This point right here is higher than the points around it. So this would be what we call a relative maximum. And then this little guy down here would be considered a relative minimum because it's lower than the points around it. So again, it's not an overall max or min, it's just relative to the points near it, if it's higher or lower. So some functions might not have a max or min, or they might have more than one, depending if they might have a few of these little swoops going on. So the next thing we're going to talk about are two different things that use interval notation. So we mentioned an interval notation a little bit in the last lesson, but an interval is going to be, again, a set of numbers, and we always use x values for your interval, not y's. So we talked about also if we should use parentheses versus brackets on our interval notation. So open intervals use the parentheses. That means that you can't actually touch the value. And then closed intervals are going to be brackets. So most of the time you'll run into the open intervals, and every once in a while you'll get those closed brackets as well. So we're going to be using that interval notation, looking at the next two characteristics. So the first type is we are going to be looking at our graphs to see if they are increasing versus decreasing. So a function f is increasing when it is rising or going up from left to right, and then we call it decreasing when it's going down from left to right. So increasing is going up from left to right, and decreasing is going down from left to right. So we will be looking at graphs and writing the intervals on when they're increasing and then intervals when they're decreasing. And again, we'll use those x values for that. And then the other type of characteristic that we'll use intervals for is to tell if a function is positive or negative. So positive and negative has to do if it's above the x-axis or below the x-axis. So like if I have my little graph here, let's say I have this parabola. A positive graph is going to be when it is above the x-axis. So from here to here, it's positive. But then once it crosses beneath the x-axis, this would be negative, and then this would become positive again. So here's the positive area. Just kind of shade it. And then the negative area is when you're below the x-axis. So positive and negative. And so we'll be writing intervals for that. So like on this one, I would say it's coming from negative infinity, and let's say it's crossing at 1 or -1, and then from -1 to 1, it would be negative, and then from +1 to infinity, it's positive. So stuff like that. And then the last thing we're going to do is we're going to talk about end behavior. So end behavior, we mentioned a little bit on the very first lesson, But end behavior is saying what's happening when your graphs are going to the extreme far left or far right. So when it's going to positive infinity versus negative infinity. Is your graph going up? Is it going down? So we talked about how even functions are going to have either 2 going up or both ends are going down. And odd exponent functions are going to be in opposite directions. So you might be going down to up or up to down. So hopefully that kind of rings a bell. We are going to be writing these in a specific way. So I'll get to that in a little bit, but we're going to be saying like as x goes to like either negative infinity or positive infinity, what is your function f of x, or what is y doing? So kind of think like as I'm going left, what is my graph doing? So like if I'm doing, let's say we're doing this guy right here. As my graph of I'm going to the left to negative infinity on my x-axis, this left side of my graph is going up for y. So I would say it's going up to positive infinity. But then I need to do the other side as well. So like if I'm going to the right for forever, so as x goes to positive infinity, what is my function doing as I go to the right? So you're kind of thinking as I go to the left, am I going up or down? As I'm going to the right, what am I doing? So if I look on this graph again, if I'm going to the right for forever to infinity, this graph just keeps going up to infinity. So I would say it's going up to infinity. And we just use these little arrows and infinity symbols to say that. And as you get into higher math classes, you'll start to use what we call limit notation. It's really similar to what we're writing right here. But limits you'll learn about in calculus. So we're not going to get into it too much right now. But notice they have like the little x with an arrow. So this one's saying is x goes to negative infinity. And then what's your function going to, kind of. So it's almost the same thing as what we're writing here. We're just not going to write the limit part. But you might see this in your future math classes. So, okay. And then we've also talked about symmetry. We talked about symmetry last time. So a function is symmetric over the y-axis, if I can like think of a mirror image and flip it over. Mathematically, how we say that is if I can take a point over here and I look at the point on the other side, this point is at 2, 2. This point is at negative 2, 2. So for a graph that is symmetric across the y-axis, you're going to have this pattern right here. For every point xy, there's going to be a point negative xy. So notice that the x switches signs, but the y stays the same. So like our height stays the same, but we're just going from positive 2 to negative 2 on the other side. So, oh, and then I'm just going to write, this is what we call even symmetry. Okay. And then on this next one, we have, this looks like a cubic function right here. And then last time I told you a good way to see if it's a cubic function is if you can spin that graph and it looks the exact same, which our graph does, then it's an odd function. So that's kind of a good little trick. But mathematically, if I look at the points here, this point is over 2, up 1, so 2, 1. This one is back 2, down 1, so negative 2, negative 1. So notice the sign pattern here is if I take a point xy on my graph, I'm going to have the opposite, negative x, negative y. So to flip around the origin, both points become negative, versus on the one up here, only the x's switch. So it's flipping kind of twice. It's flipping across and across to get negatives. So this would be your odd symmetry. Again, you'll notice on the odd symmetry, it's usually things that have odd exponents. And on the even symmetry, it's going to be things that have even exponents. So like your x squareds, x to the fourth, things like that. And then you will run into ones that have no symmetry. Notice that this is a parabola. Usually a parabola, we would say, is a symmetrical shape, but it's a very specific type of definition. In order to be considered an even or odd symmetry, it has to reflect over the axis. So since this graph has been shifted, I can't flip it right over the y-axis anymore. My new line of symmetry would be right here at -1. So I could flip it across the point -1, but in order to be called even, I need to be able to flip it across the y-axis. So since this has been shifted, we say it has no symmetry, at least to our definition of even and odd. So we could say it's symmetrical about the line x equals -1, but it's not even symmetry. So just kind of keep that in mind. It's a very specific definition of even versus odd symmetry. And if your graph has been like shifted up or down or side to side, it probably doesn't fit in that definition anymore. So I'm going to do just a couple examples with you of how you are going to be using these different key features. So you are going to be given a graph, and then you'll be asked to analyze some of those or find those characteristics that we were talking about. So I'm just going to do a couple on paper. For you guys, I think it's actually easier to do on your online homework than it is to do on the paper homework. So you almost have it easier now that your homework is online. But we are going to first just graph the function. Then we're going to find the x and y intercepts, see if it has any max or minimums. And then we're going to look at the intervals where it's increasing or decreasing, intervals where it's positive or negative, what's the end behavior, and what's the symmetry. So these do take a minute, so I'm not going to do too many of them just for sake of time on our video. But let's look at this first one. So we have the function f of x equals 2x plus 3. So if I get my graphing calculator out, and we go and graph this, I'm just going to type in 2x plus 3 and then click graph. And we do have just a line here, a linear function. So when we graph this, let's just put our axis on first. Let's say here's our y-axis. And then let's say this is our x-axis. Let's see if I can draw a straight line. That's the real trick. Okay. And then it is going through 3 on our y-axis, and we have a slope of 2, so that kind of makes it a little bit easier to graph. So I'll just get a couple points here. And then again, here's the trick, is making a straight line. Wow, that was really bad. Okay, let's see if I can fix that bottom. Okay, so there's our graph. So there's our part A. Part B was to identify the intercepts. So we already see what our y-intercept is. So I'm just going to put a little thing over here. Let's find our x-intercepts and our y-intercepts. So our y-intercept we already know is going through 3. So I'm just going to put that. It's at 0 for x, but up 3 for y. But then we need to get our x-intercept, and it doesn't look like it's going through a specific point. So I'm going to show you how to get that on your calculator if it's not going right through a point, somewhere between -1 and -2. So in your graphing calculator, there's this little calc menu in blue. So you're going to push second and then calc. And then these are going to be a whole bunch of different things that we can use for our key features. So the first thing we want is to find our x-intercept, which is what we call a 0. So remember, another word for x-intercept is a 0. So we're going to go to that, and you see this little flashing dot right here, and it says go left bound. So right now it wants you to go left of your intercept. So I'm just going to use my left arrow key to go past it. So I'm kind of going like left and down at the same time. It doesn't matter how far left you go, you just need to be past it. So don't worry too much about how far left, but push enter. And then now it says to go right bound. So I'm going to use my right arrow key to go past it a couple times. Again, it doesn't matter how far you go. Push enter. And you see how we got these two arrows from the left and the right? It's kind of like it's sandwiching in on that point. And now they're saying guess. They want you to get that point as close as you can. And sometimes you can't get right on it. I'm pretty close here, but sometimes it might not let you get that close. Just get as close as you can and push enter and you're okay. Here's your x-intercept. You're at -1.5 and 0. So that's our x-intercept. And then really quick, if you don't have a graphing calculator like this, you can go to desmos.com. Let me just write that right here. Desmos.com is a really good graphing website. They also have an app. So you can go to your app store and just download Desmos. And actually, they almost work a little bit nicer, because on Desmos, if you have it on your phone, you can literally just like tap on the intercept with your finger, and it just gives it to you. So sometimes it's a little bit easier. But just know on tests and things like that, usually you're not allowed to tap your phones, so keep that in mind. Okay, so we have our X and Y intercepts. The next part is our max and mins. So remember, max and mins, these are going to be points that are higher or lower than the ones around it. Well, with a line, each point is going to be a little bit higher or a little bit lower. So these lines don't have max or mins. So this one I'm just going to put none. Kind of makes our job easy. Okay, part D is see where it is increasing versus decreasing. So I'm just going to abbreviate. Increasing versus decreasing. So remember, this is going to be in our interval notation. So we always go from left to right, like in the direction that we read. So if I'm on this graph, if I pretend I'm walking on it from left to right, I am walking up. So I am increasing this whole time. I'm never decreasing. So our decreasing is none. But for increasing, it's from forever to the left, forever to the right. So we're going to do parentheses, negative infinity to positive infinity. Okay. And then on part E is our positive and negative intervals. So remember, positive and negative. Sorry, I have my window open. Someone's rubbing their engine. I don't know if you guys can hear that. For positive and negative, it's when it's above the x-axis versus when it's below the x-axis. So here's our positive section, and then here's our negative section. And then notice it's always going to switch where your x-intercept was. Our x-intercept was at negative 1.5. That's going to be your cutoff. So if I'm doing the negative section, I'm coming from negative infinity on my x-axis. Pretend I'm walking along my x-axis. I'm coming from forever to the left up until that negative 1.5. So we're going from negative infinity to negative 1.5. And then as soon as I hit negative 1.5, I'm going to infinity in the positive section. So negative 1.5 to infinity, you're going in the positive. And remember, we're always going off the x values, not the y's here. Sometimes I have students trying to do the y value because they're thinking kind of vertically with the negative and positive, but we always go off of the x-axis value. Okay. F, let's do our end behavior. So you're always going to have two things for end behavior. Going to the left, which is when x goes to negative infinity, and then you're also going to check going to the right as x goes to positive infinity. So remember, this is a negative infinity, this is positive infinity. So if I'm going to negative infinity for forever on my x-axis, what's my graph doing? And on this one, it is going down. So for our y, think of that as being negative infinity, positive infinity. So we're going to say as I go to the left, negative infinity, my function is going to negative infinity as well. As I go to the left, I'm going down. And then as I go to the right for forever, my function is going up for forever. So as x goes to positive infinity, so is our function. Our function is going up to infinity. So you'll always have two. Think of this as being like your left and your right. What is your function doing as you go left, and what's your function doing as you go right? And then G for symmetry. Remember, it's a very specific definition. Normally a line would be odd symmetry if it was going through the origin. But because this has been shifted, we're going to say none. Okay. So it's been 19 minutes. Do you think we have enough time to do another one? Let's try and do one more. Maybe we can go really fast on it. Let's do, this one's a cubic. I want to try and do one a little bit more complicated than just a line. So first, let's graph it. So go back into your y equals and clear this out. But we have a negative x to the power of 3. And then plus 2x. And let's graph this guy. So we've got a little cubic function with those little swoops in it. And then, so if we graph it, for the sake of time, I'm not going to worry too much about being super accurate on this graph because it's just for this video. So I'm just going to say we've got this little swoop. Oh, no, that's not perfect. Okay. So we've got this little graph right here. Part B was doing our x-intercepts and our y-intercepts. So we've got more on this one. We're crossing 1, 2, 3 times for our x-intercepts. So if we go into our calc menu again, go to second calc, and we're going to do the zeros. We're going to have to do this 3 times since we have 3 of them. So again, we're going left bound first. So you move your left arrow key past your intercept, push enter. Use your right keys to go past it, push enter, and then get as close as you can. See how I can't get quite on the line? It's a little bit above or a little bit below. Just get as close as you can, that's okay, and push enter. So we have an intercept at negative 1.41, comma 0. So there's one of them. Let's do the middle one next. So I'm going to repeat that process. Go to second calc 0. And then, so here's my intercept. I'm going to go a little bit left of it, push enter, a little bit right of it, push enter, and then guess. And it is at 0, 0, which is what I thought. So we have one at 0, 0. And then let's do the right one. So repeat again, second calc, go down to 0. And then we want to be left of it. So if this is my intercept, I want to be to the left, push enter. I want to be to the right, push enter, and then guess. And now we have positive 1.41. So you'll see a lot of times on these odd shaped ones that have that odd symmetry that your intercepts are going to be kind of reflections of each other. We have a negative and a positive, so that happens quite a bit. And then our y-intercept we also know already because it was just going through 0, 0, which was that middle x-intercept. So 0, 0. So we're done with our intercepts. Hey, part C are your relative max and mins. We do have these on this one. Since we have these kind of little hills and valleys right here. We have a minimum down here and a maximum down here. So I will show you how to do that on your calculator. You're going to go to your calc menu again. Second calc, but instead of doing 0, you're going to do minimum or maximum, whichever one you're finding. Let's do our minimum first. And you'll see that little dot pop up again, and it's asking you to go left of it. So if I'm doing my minimum, that's going to be this little bottom point right here. We want to go to the left of it, so I'm just going to go over a couple times. Now it's saying to go right bound, so go over a couple times, and then now guess. And so then our minimum is at negative 0.82. Let's round to 2 places. Oh, that's my max. My min is at negative 0.82. And then for the y was at negative 1.09 if I rounded 2 places. And then we're just going to repeat that and do the maximum. So second calc, but this time go to maximum. And again, we want to go left, right, guess in the middle. So if here's my maximum, I'm going to go left of it, push enter. Go right of it a couple times, push enter, and then guess as close as you can. And we get positive 0.82 and positive 1.09. So again, we have kind of that symmetry, which is making these points be just positive and negative of each other. And you'll see that in those odd functions quite a bit. Okay, the next section, part D, is when is it increasing versus decreasing. So on this one, remember we always go left to right. So if I'm going left to right, I am decreasing until I get down to this minimum. Once I hit this minimum, I switch, and now I'm increasing till I hit my maximum. And once I hit my maximum, now I'm going to be decreasing again. So you'll notice if you have multiple like increasing and decreasing areas, they're going to be switching at those max and min points. So we already know those points, which is nice because we don't need to go find them to write my interval. So if I'm coming from the left first, I'm coming from negative infinity up until I hit this point, which remember that point, which is not accurate on my graph, but my point was at negative 0.82. Remember, we always take the x value, not the y value, even though we're kind of going vertical here. We're using that x-axis as our label. So I'm decreasing from negative infinity until I hit this point, which the x value was at negative 0.82. And then once I hit negative 0.82, I'm increasing until I hit my maximum, which was at positive 0.82. So I'm increasing from negative 0.82 to positive 0.82. And then I start decreasing again. So when we have multiple increasing and decreasing parts, to write the second section of your interval, you're going to do the little union symbol. It's kind of like a giant U. So we're going to do that little union symbol. We're saying we're decreasing here and in the next section. So that's what that little union symbol represents. So now we're decreasing from this maximum till forever. So from positive 0.82 until positive infinity with that little union in the middle. So again, just make sure you're always using the x value, not the y value. I have some students who always seem to get that flipped because they're thinking, oh, I'm going down to 1.09, but we're using the x value, not the y. So just careful with that. And then the next section is positive versus negative. And again, the positive and negatives switch at your x-intercepts, which we also already found. We found negative 1.41, 0, and positive 1.41. So I'm positive from negative infinity until this x-intercept, which was at negative 1.41. So I'm going from negative infinity to negative 1.41. And then once I hit negative 1.41, I stay negative until I hit this intercept, which was at 0. So from negative 1.41 to 0. And then once I hit 0, I became positive again for this little swoop right here. So from 0 until 1.41, I'm positive. So to write the second interval, again, you're going to do that little union symbol. And we're saying we're positive from 0 to 1.41. But then once I hit 1.41, I switch to being negative again. So we're going to union it and say from 1.41 until positive infinity. Remember, we're going off that x value, so from 1.41 to infinity, not negative infinity. Okay, and then f is our end behavior. So remember, you always have 2. You'll have as x goes to the left to negative infinity, and as x goes to the right to positive infinity. What is your function doing? So as I go to negative infinity forever on my x-axis, my graph is going up to positive infinity. So my function is going up to positive infinity. And as I go to the right for forever to positive infinity, this time my function's going down to negative infinity. And then symmetry, we do have symmetry on this one. Let's see if I can squish it on here. My graph's not very good, so ignore my ugly picture, but our graph is that odd symmetry where we had all of those nice reflections. You can kind of tell again by our points how everything matched except for the signs. Or if we flip our graph upside down, looks the exact same. So this has that odd symmetry on it. Okay, so that's hopefully those two examples give you kind of a good idea of what you'll be doing in your homework. I actually think your homework's easier because you don't have to do all of it on paper, so I think it's easier to do it on the computer actually. So we have intercepts, max and mins, increasing, decreasing, positive, negative, and end behavior. If you need to, you might need to watch these sections a couple times until you get it. I went kind of fast just to kind of save some time. We're already like 28 minutes. But if you need to, go back and rewatch it, or you can always email me and we can set up a time to work together and I can help you out. But I hope you guys are having a good day. I'll talk to you later.